In this video, we're going to be finding the derivatives using implicit differentiation. So you're sitting there and saying, what is implicit differentiation? Well, they're going to be equations that are not written as y equals. In other words, there's going to be a bunch of y's and there's not going to be just y equals. We're used to seeing y equals, those are called explicit functions. All right, so let's go ahead and look at the objective. Determine whether a function is written explicitly or implicitly. Find the derivative using implicit differentiation. Find the derivative at a given point of an implicit function. All right, so here we go. A function is said to be written explicitly if it is solved for the variable y. So I want you to look at these three examples, right? y equals, and there's a function of x. Y equals a function of x. Y equals a function of x. If a function is said not to be written, is said to be written implicitly if it is not or cannot be written as y equals f of x format. Example, look at this ugly looking function. There's going to be a y cubed and a y there. In this scenario, they didn't solve for the y. You could solve for the y, but you could take the derivative without having to solve for the y. And in this scenario, you have sine of y is going to equal to a y. So it'll be very hard to solve for the letter y because y is here, but then over here the y is in the form in a trig function. All right. So what are the steps in order to find the derivative implicitly? Well, what you're going to do is you're going to take the derivative with respect to x. All right. Now here's the only thing that you have to know from today's lesson. Every time you take the derivative of y, you pretend it's an x, you do the power rule, you do whatever the rule is, the derivative, you pretend it's an x, you take the derivative, but then you're going to put a dy dx beside it. You're going to multiply it times dy dx. It doesn't matter. If there's three different terms with y's in them, and you take the derivative of each term, you're going to put a dy dx for every single term. Then after you have that, you might end up with more than one dy dx. So if you have more than one... Sorry about that. So every time you take the derivative of y, you must put dy dx. Now, if you end up with more than one dy dx, you have to put all the dy dx's on one side of the equation, and the ones that do not have a dy dx, you put it on the opposite side. And then to go from more than one dy dx to one, you have to factor it out. And then finally, once you factor it out, that means you're multiplying it, then you divide to leave dy dx by itself, right? So what you're going to do is you got to be able to see some examples, right? So here we go. So what's the derivative of x cubed? The derivative of x cubed is 3x squared. That's not the hard part. The derivative of y cubed is, pretend it was an x. It would be 3x squared, right? But now it's not an x, and it's going to be 3y squared. But we took the derivative of a y. So we're going to put dy dx. Okay, remember what I said. Every time you take the derivative of y, you must put dy dx. So now what's the derivative of 3x? It's going to be a 3. The derivative of 2y is going to be 2. But I took the derivative of y, so I have to put dy dx. And the derivative of any constant is going to be 0. Now, in this scenario, I have a dy dx on the left side and I have a dy dx on the right side. So I'm going to move them to one side. 3y squared dy dx minus 2 dy dx, and now this guy didn't have a dy dx, so I'm going to move him over to the opposite side. I'm going to have a 3, this 3 here, minus 3x squared. Now, how do I go from 2 dy dx's to 1 dy dx? I am going to factor it out. So I'm going to have dy dx is going to have, I'm going to be left with 3y squared minus 2 is going to equal to 3 minus 3x squared. And then finally, what I'm going to do is I'm trying to solve for dy dx. I have to get rid of this quantity there. So I'm going to divide by 3y squared minus 2. I'm going to divide by 3y squared minus 2. So that means that dy dx is going to equal to 3 minus 3x squared over 3y squared minus 2. And this is the derivative. This equation will help me find the slope of this relationship at any point. Now, did you notice something specific from all the derivatives that we've done in the past? In this one, it has my derivative has x's and y's. So let's try another one. Okay. So here we go. I have the derivative of this. So in this scenario, I'm going to take the derivative of that, which is 2x plus 2y dy dx is going to equal to 0. And now what I'm going to do is I'm going to solve for my dy dx. So I'm going to subtract 2x from here. I'm going to subtract 2x from this side. So I'm going to have 2y dy dx is going to equal to negative 2x. So then I divide by 2y. I divide by 2y. So that means that dy dx is going to equal to negative x over y. But now they want the slope at 3, 4. So I'm just going to substitute negative 3 over 4. And this is going to be the slope of the tangent line at 3, 4 for this function. Okay, so let's try another one. This one is a beautiful question. I love putting something like this on the exam because I'm going to notice that there's a product rule. So what's the derivative of x squared? The derivative of x squared is going to be 2x. The derivative of y squared is going to be 2y. The derivative of this, though, is going to, I'm going to have to use the product rule. So I'm going to rewrite it up here. This here is going to be my a bubble, and this is going to be my b bubble. I like to use ABBA, right? A prime b plus b prime a. So those of you that are watching this video, it says, what is ABBA? Yeah, I just use a different notation. Okay, so the derivative of my a bubble, did you notice something unique? Did you see how I put the minus with the x in the a bubble? Yes, that's very important because if not, you're going to have to distribute, and a lot of students forget to distribute. So it's easier to just include it in the a bubble. So the derivative of my a bubble is going to be negative 1 times my b bubble, which is y, plus the derivative of my b bubble, which is dy dx, times my a bubble, which is negative x, is going to equal to the derivative of 1, which is 0. All right? Now, I did forget to put dy dx right here. So now, I have to move the ones that are not dy dx's over to the other side. So I'm going to be left with 2y. Oops, let me change the color on this. I'm going to have 2y dy dx, right? And then I'm going to have minus x dy dx is going to equal to negative 2x plus y. So I'm going to factor out my dy dx, and I'm going to be left with 2y minus x is going to equal to y minus 2x. And if you notice, I rearranged it. So now what am I going to do now? I'm going to divide by my quantity here, which is 2y minus x. I'm going to divide by 2y minus x. So this and this reduce to a 1. So that means that my slope, dy dx, is going to equal to y minus 2x over 2y minus x. And this is going to be my derivative function. All right, let's try one more. All right, one more derivative function. Here we go. So let's take the derivative of this. So the derivative of the first term is going to be 5x to the 4th. And here I'm going to do my ABBA rule. So this is going to be my a, and this is going to be my b. Oops, that's an ugly looking b. So the derivative of my a is going to be 1 times y cubed plus 3y squared, that's the derivative of my b bubble, dy dx, times my a bubble, x. Plus, now I got to do ABBA again. So this here is my a bubble, and this one is my b bubble. So that's going to be 2x times y, plus the derivative of y is 1, dy dx, times x squared, plus 4y cubed dy dx is going to equal to 0. Alrighty, so now if it has dy dx's, I'm leaving it on the left. If it doesn't have dy dx's, I'm moving it to the right. So that guy right there, Mr. Quintana, does not have a dy dx, so I'm moving it over, 5x to the 4th. This one does not have a dy dx, so I'm moving it over, minus y cubed. This one does have a dy dx, so I'm going to have 3y squared dy dx. This, oops, I'm forgetting that x that's located there, so I'm going to put the x in the front here. The next one does not have a dy dx, so I'm going to move it over, minus 2xy. This one does have a dy dx, so it's going to be plus x squared dy dx. And this one does have a dy dx, so I'm going to be left with plus 4y cubed dy dx. So I factor out my dy dx, and I'm going to be left with 3xy squared plus x squared plus 4y cubed. It's going to equal to negative 5x to the fourth minus y cubed minus 2xy. And then finally what I'm going to do is I'm going to divide everything by this ugly little quantity here, 3xy squared plus x squared plus 4y cubed. Sorry about my writing. And I'm going to divide it also on this side, so 3x squared, y squared plus x squared plus 4y cubed. And this here is going to be my derivative. That will help me find the slope of this relationship. And that concludes the video on implicit differentiation.